Hi there. In this tutorial, you're going to learn about object-oriented programming. Now, previously in programming, programs were written in a kind of logical, sequential manner. So, the program took in input, processed it, and returned an output. So, step-by-step instructions. In object-oriented programming, we tend to model our programs to imitate the way objects appear in real life. Now, let us just imagine how objects are in real life. I am not showing you any code yet, so let your mind be free. So, you have cars in real life. These are objects. You also have planes in real life. You have your bicycles. Even you can be referred to as an object. Now, each of these objects has a state and a behavior. You might ask, what do I mean by state and behavior? Now, if we go further to check the state and behaviors of some objects, a dog has a state of name, color, breed, and we can call behaviors such as barking, fetching, or waggling its tail. So, think of any object and what the state and behavior is. So, state is more like its characteristic, and the behavior is like what action it can perform. So, a dog has a state, it has a name, like the owner must have given it a name. It has a color combination, and that is what it has. It has a breed. Is it Alsatian, German Shepherd? And it has hungry. Is it hungry or not hungry? Though some might be hungry all the time. Now, it has a behavior. These are like actions: barking, fetching something, or waggling its tail. Bicycles have state and behavior. So the state of a bicycle is the current gear. Which gear is it currently? The current pedal cadence and the current speed. These are states of a bicycle. But the behaviors, the actions of a bicycle: changing a gear, changing pedal cadence, applying brakes. These are actions. Also, you watching this, you have a state and a behavior. You have a state: age, sex, eye color. Now, these are your characteristics. You also have a behavior: eating food, running, and exercising. Hopefully, you eat food and exercise. So, now these are your states and behavior. And let your mind run. You can think of any object and check out the state and the behavior. So either the state is what is the characteristic of the object. So let's imagine your phone or your laptop. So your phone can have a state of phone color, operating system, battery level. Then it can have a behavior of switch on, switch off, make a call. So these are like actions. So in programming, an object stores its state in fields. So we call what we'll call a state a field. Now this can be called variable in some programming languages. You'll normally see a variable that belongs to an object. That variable represents the states of the object. So you have fields and methods, or variables and functions. So these are the states and behavior of the object. So you can have an object, your phone, and we'll call the state field or variable and the behavior method or function. You understand that an object has a particular design. So the design they used to build a laptop is different from the design they used to build a phone. They wouldn't bring a laptop to you and call it a phone because it doesn't have the same design. So there is one design it has to have to be called a laptop. Now, you have different cars. You can have a car A. You can have another car B. Another car C. All these are objects, but all of them have the same design. They all use the same blueprint design to construct the objects. Now, this blueprint can have a standard set of fields and methods. So for a car, it can have car color, engine type, amount of seats, and for the methods, you can have start engine, stop engine. So even if you create 1 million cars, all of them are going to use this design. Now, one car can use a different car color. Let's say car A decides, I don't want to be blue, I want to be red. That is not a problem. Even a last car can say, I want to be yellow. But all of them still use the same design, that you must have a car color, engine type, number of seats, and it should be able to start and stop the engine. If you want to change the car color, you can do so, but you must have a design that has a car color. Now, let's look at some fields and methods that we can use for a car. So we have fields such as fuel level, the color of the car, the number of the seats. Then the methods, we have start engine, stop engine, and apply brakes. All this will be in the design so that any car you have or you want to create should have these fields and methods. So from this design, you can use to create numerous cars. Just like where you want to build a house, you have a blueprint. From that blueprint, you can decide to build 10 houses from it. The blueprint itself is not the house. The blueprint is the design. The house is the object designed from the blueprint. Programming, the blueprint is called a class. That is what we call the design that we use to create objects. You can have different classes that create different objects. So you don't need to have one class to create different objects. If you have a teddy bear class, you can have a woman class, a football class, and a dog class. All these classes will have different fields and methods that you use to create objects. So a teddy bear class will create a teddy bear object. A dog class will not create a football object. This is a simple Java code. I'm going to make this simple so that even if you don't do Java, you can understand it. Now, this is a class for a car. So you have public class car. It is an empty class that doesn't have any state or behavior. Or in more correct terms, it doesn't have any field or method. So you have public class car. Now, we need this car design to state some characteristics so that anytime we're creating a new car, it should have specific fields and methods. So you have fuel level, color, and number of seats. It has the fields. What of the methods? So let's create and add these methods to it. So now added the method start engine, stop engine, and apply brakes. And that's it. The design for this car is complete. So this class itself is the design. Remember I said that the design itself is not the object. The blueprint of a house is not the house, but you use the blueprint to create a house. So using this design, I can use the car class design to create different car objects. So how do I do that? Remember that the name of this class is car. So in order to make a new object using this class in Java, this is what I do. The name of the new object I want to create is car A. So I say car A is equal to new car. The first word there, car, represents the class. The second word, car A, represents the name of the variable. And I say car A is equal to new car. That new car in Java is saying create a new instance of the car class. That is, in real terms, you're trying to build up a new car using the design, and you're assigning the design to the variable car A. In modern Java, you can shorten this by using var. So var car A just says that car A is a variable. And when you say equal to new car, you're saying create a new car and assign it to car A. You could create other objects, car B, car C, car D. I am going to demonstrate now using live code so you could see what it involves. So currently I am in my class called public class car. So now I can create the states and the behaviors. That is the fields and the methods. So I mentioned that we use string, let's call it car name. So the name of the car or the car brand name. We could also say int for level, and we can also say string engine type. So these are three fields that belong to this class. Let's create some methods. So say public void start engine, and we say public void stop engine, and we can also say public void slow down. So these are three things the car object should be able to do: start engine, stop engine, and slow down. So we come to our main class to create the objects. So we have car A is equal to new car. Now I've created a new object. This car A is the name of the object. New car creates a new car and assigns it to this variable. I can create a different car. Car B is equal to new. So now there are two cars. I can also say car C is equal to new car. And all these are different objects created with the same class. The same class was used to create car A. The same class was used to create car B. The same class was used to create car C. Car A, car B, and car C can all have different characteristics. Like car A I can set the floor level to be from 1 to 10. I can set it to be 8. And car B, I can set the floor level to be 2. Now, car A and car B both have floor level, but they have different values. The same way they can have car color, but have different values. But they are all built from the same design that states that you must have a floor level. So using this design, we created new objects, and that is how object-oriented programming works. This isn't a Java tutorial. I wanted you to understand the basics of objects and classes, no matter the language you are learning. So in the next tutorial, we're going to talk on inheritance in object-oriented programming.